Hi. Now let's go over to the bomb diffusing robot by laser beam, the transmitter section. In this section, first we go with a power supply arrangement where we have a 6-volt battery and we have a blocking diode here again for the purpose of doing any reverse polarity. It also has an advantage that this being a silicon diode, 0.6 volts is dropped across this, so 6 minus 0.6, 5.4 volts will be available here, and that 5.4 volt is taken to the entire circuit to work, including the microcontroller that requires 5 volt. Though the microcontroller requires 5 volt here, but giving a voltage of 5.4 volt doesn't much affect the microcontroller, so here we get roughly about 5.4 volts, though we have mentioned here 5 volts. And the other things are very standard that we have discussed. For any microcontroller we require a crystal, and then there are capacitor, there are reset pin. The reset pin is connected to a capacitor and a resistor. They are all separately explained what is the purpose of this and how they are connected. And the rest all is the input and output pin and the HT12D and 12E, which are separately explained in separate audios, and also the transmitter and receiver, which is used in combination with HT12D and 12E. HT12E is the encoder IC, HT12D, which is used in the receiver, is the decoder IC. And as far as the microcontroller is concerned, we are making use of certain I/O pins here, and those I/O pins are connected to several push to on switches, and those switches form the operations like forward, backward, left, right, arm up, arm down, and so on. Here is arm down and arm open, arm close. All these functions are nothing but push button switches connected to I/O pins of the microcontroller. It's a 20 pin microcontroller, that's why we've taken 89C2051 to us to make the transmitter handheld and very small. And as regards the data pins are concerned, we have discussed this at length as to how to 12E and 12D are connected, and this is the encoder out pin. This encoder out pin, this 17 is the encoder out pin. The encoder out pin goes to the transmitter, and transmitter transmits the data serially. And there are the data pins, that is these 4 pins. These data pins are connected to the microcontroller for the purpose of sending these switch commands to the switch commands from the microcontroller to the encoder, which in turn gives the serial data to the transmitter, which is transmitted and received, and finally the received data appears at the receiver decoder, and that decoded data is fed to the microcontroller for doing respective work as for the motor movement, which we have seen using L293D. The transmission enable pin, which we have discussed, is also connected here. Instead of connecting to ground, we can always connect this pin to ground, but if you can write a program in such a way that transmission enable pin is also taken into microcontroller, and only when the transmission enable pin works, then only the data is transmitted. In the audio, we have discussed about the ST12V, 12D, where here we have taken 1 megohm and 100K in series. That means 1.1 megohm. And we have discussed that this value, that is the R value of this, has to be 50 times than the receiver value. So you must have seen in the receiver how value we have put for matching the frequency. and that is how, based on, and then we also have a laser pin. We have a laser command. When this is given ground, and the command, this command goes 0, when this command goes 0, as per the program, the data output comes accordingly, and that data is processed by ST12V, which is sent serially to the transmitter, and transmitter data transmits, and receiver receives it, and then understand which data has appeared, and accordingly the output is generated. Thank you.